The original Apple TV is one of the most fascinating devices Apple ever made. At its release in 2007, it was overshadowed by a different device that you might have heard of. And honestly, it should have been. When it was released, the original Apple TV was one of the worst Apple devices that you could buy. The stock operating system, a modified build of macOS 10.4.8, really held back the hardware with its lack of basic functionality. The Apple TV was completely tied to iTunes. It could only play media either purchased on iTunes or synced over with it, and it didn't support network shares or USB hard drives in any capacity. Watching home movies or rips of DVDs required tediously importing everything into one of the worst programs ever created. The original Apple TV even has the honor of being one of the only devices Apple ever removed support for in iTunes. I didn't even know Apple had the ability to remove anything from that god-awful app. So why is a device long since abandoned by Apple so interesting to me? That's right, the original Apple TV has an Intel processor. It's a Pentium M-class CPU running at 1 GHz with a TDP of just 5 watts. The rest of the hardware is what you'd expect from a PC too, with the TV shipping with 256 MB of soldered-in DDR2 RAM, a laptop-style IDE hard drive of either 40 or 160 GB, and an NVIDIA GeForce Go 7300 graphics card. Now that's not exactly breaking any speed records. In fact, it's the slowest Intel machine Apple ever released, but it's well within the requirements of Windows XP.
Here I am, next to the Windows XP wallpaper. I made it.
Windows XP needs no introduction. It's one of the most iconic operating systems ever made. It was the operating system that introduced computers and the internet to millions of millennials and early Gen Z, from its release in 2001 to its eventual end of support in 2014. I mean, unless you were one of those weird people with a Mac, it was really the only good choice of operating system for 8 years of its life. No, I said good operating system, not Windows Vista. The original Apple TV fits comfortably above nearly all of Windows XP's system requirements. So why did it take nearly 18 years for someone to install Windows XP on the Apple TV? Well, there's one system requirement for XP that the Apple TV does not meet: the requirement for BIOS-compatible firmware. Like Intel Macs, the Apple TV uses EFI firmware instead of the legacy BIOS standard that really hasn't significantly changed since the early 80s. Microsoft didn't support EFI on non-Itanium versions of Windows until Windows 8 though, so Intel Macs used a feature called the Compatibility Support Module, or CSM, to boot Windows. The original Apple TV, though, doesn't have a CSM. After all, it was never designed to run any operating system other than its stock OS. In fact, it doesn't even have normal EFI firmware. See, the original Apple TV was, as far as I know, the very first Apple device that did any sort of boot time OS verification. It's hard to believe since these days Apple puts verification on anything that moves, but this was the very first time they did so. The verification worked in a very simple way. When you turn on your Apple TV, the firmware checks the hard drive and any USB drives for EFI files in a few predetermined locations. That's normal behavior that's the case on every EFI-based computer, but what's different on the Apple TV is what happens next. Once it finds a file, it checks to see if that file is signed by Apple for use on the TV. If it is, then the firmware executes it without any issues. But if it's not, the firmware moves on to the next location and checks that one. Only a small handful of verified files exist, and the only one we care about is the macOS 10 bootloader that shipped with this thing, which is called boot.efi. However, Apple did such a poor job of locking down the TV that in just 16 days the verification was cracked. Edgar Husek, part of the team that brought Linux to the Intel Mac for the first time, was responsible for the crack and the first Linux bootloader for the Apple TV. How did he do it? Well, the verification wasn't exactly cracked per se, more so bypassed. While the firmware goes to great trouble to verify the EFI executable, there is no verification at all on the next stage up, that being the kernel. If we replace that file with a file containing our own code that looks the same, the Apple TV will load it without question. When booting Linux, removing the hard drive isn't even necessary thanks to the singular USB port on the back, the savior of Apple TV hacking. This port is disabled in the Apple TV stock operating system and is officially listed on Apple's website as "for service and support." As far as I know, this is the only time Apple ever included an undocumented port on the exterior of a consumer device. When a USB drive containing an Apple TV recovery partition is inserted at boot, the TV will just boot from it, so long as it finds Apple's boot.efi on there. Running a Linux distribution with the Kodi Media Center software used to be somewhat popular on these things. Kodi had numerous features the Apple TV's stock OS couldn't even dream of, such as media playback from places that aren't iTunes. In 2007, the Apple TV was more than powerful enough for the task. But by the time OSMC, the last prepackaged Linux distribution for the Apple TV, ended its support for the device in 2017, it was almost unusably slow. And so, just 7 years after Apple stopped selling the TV, the open source community more or less declared Apple TV hacking dead. This state of near abandonment only furthered my interest in getting Windows running on the Apple TV though. And so I began to investigate what modifications to Windows I needed to make to get it running on the Apple TV. And what I determined was the following. Windows XP has essentially 3 dependencies on legacy BIOS: the bootloader, the basic VGA driver, and the MS-DOS compatibility layer. The MS-DOS compatibility layer is not necessary to boot Windows, so pretty much 2 things will have to be either modified or replaced to get Windows running on the Apple TV. Fortunately, for both of those things, I have a really good starting point. Let me introduce you to ReactOS. ReactOS is an open source operating system designed to be binary compatible with Windows applications and drivers. ReactOS has been around for over 25 years and is still in alpha. It's currently targeting Windows Server 2003 for binary compatibility. That's basically Windows XP. If you're a ReactOS developer, pretend you didn't hear that. Importantly for us, ReactOS's bootloader, which is known as Freeloader, can boot Windows versions from 2000 all the way up to Windows Vista. Freeloader is open source and designed to be extremely portable, only requiring about 20 functions to be implemented for each platform it runs on. Ports of Freeloader already exist for the original Xbox, the NEC PC98, and EFI firmware, so creating one for the TV shouldn't be too hard. There was just one small problem, one tiny little issue that got in the way of every possible plan that I made. I didn't know how to code. That's right, I had literally no idea how to code. I mean, sure, I knew how to print Hello World in Python and HTML, but I really didn't know much else. I had never even heard of a pointer at that point, let alone know how to use one, but I was motivated to work on this. I absolutely locked in, spending about 3 days during the winter break of 2022, that's how long I've been working on this, learning the basics of the C programming language and learning how to write code for the Apple TV. Before even writing the first line of code for the Apple TV, I did something that would prove to be extremely important. I created a virtual machine that I could use for debugging my project. Using a virtual machine not only sped up the development process since I didn't have to constantly go back and forth between my PC and the Apple TV, but it also allowed me to utilize the serial port to make debugging infinitely easier. Honestly, if I hadn't been able to use the serial port, I probably would have given up on this project, since debugging everything on real hardware without a serial port would be painful and nearly impossible. It took me a while to get the hang of writing bare metal C for the Apple TV, but after a few months of experimenting with different things on and off, I figured out what exactly needed to be done to port Freeloader to the Apple TV. Like I mentioned before, Freeloader is designed to be as portable as possible. Its machine-specific code is kept to an absolute minimum, with just 28 functions being implemented differently on each platform. And in almost every case, the function from either the original Xbox or EFI ports of Freeloader is either exactly the same as the one on my Apple TV or minimally different. My Freeloader port doesn't really have that much code of my own. I just had to combine existing code together to make something that theoretically works on the Apple TV. Though notice I did say theoretically, since I still have to actually get boot.efi to load Freeloader. When I was first experimenting with Apple TV programming, I was using a compiler and linker that directly outputted the static Mach-O files boot.efi required. Being a part of ReactOS though, Freeloader doesn't compile to Mach-O very easily. It's set up to be compiled by either MinGW-GCC or MSVC to a Windows PE formatted executable. There are basically 3 approaches to deal with this. Number 1, get Freeloader compiling with a Mach-O toolchain. Number 2, compile Freeloader into a small Mach-O formatted shim program. Or number 3, convert the Freeloader PE file to a Mach-O file directly. I ruled out the first option almost immediately, since I'd either have to get Freeloader to compile outside of the main ReactOS source tree, or use a compiler and linker not used anywhere else in ReactOS for this one thing. I actually did do the second one for a few months, but it was not ideal since it resulted in a super messy multi-stage boot process. Doing things either of the first 2 ways might also pose a challenge in getting any of this code merged into ReactOS in the future, so conversion it is. There's a few ways I could go about doing this. M1N1, the open source bootloader for Apple Silicon Macs, uses a linker script to construct a Mach-O executable byte by byte. This was way too tedious and could go wrong in a billion different ways. It might also present issues with linking with MSVC, so instead I decided to write a simple program that appends a valid Mach-O header to the beginning of a PE formatted executable. Known as PE to Mach-O, it is written in C and is set up to automatically convert the PE formatted Freeloader file to Mach-O after you compile Freeloader for the Apple TV. The Mach-O file it generates is not fully spec compliant though, since all of the executable segments are combined into one, but boot.efi is fine with it, so good enough for me. The final platform-specific code I had to write was the extremely early initialization code. All this code does is set up things like the stack and descriptor tables, puts the boot argument pointer passed in by boot.efi into a place where Freeloader can find it, and begins the execution of C code. With Freeloader ported to the Apple TV, it was finally time to test out our port and see how far we can get. Oh crap, I forgot to specify what hard drive Freeloader should use. One moment. No way! No f***ing way, dude. No f***ing way, dude. And it actually worked. In VirtualBox, Freeloader got far enough in its boot process to read the virtual hard drive and display the ReactOS boot menu from an install I had on there. Awesome! What wasn't so awesome though was what happened next. For one thing, VirtualBox would throw a guru meditation error towards the end of the boot process. Changing a setting in VirtualBox allowed the kernel to load, but it errored out almost immediately with an issue related to the video driver. Thankfully, this was exactly what I was expected, since at the time there was no ReactOS EFI video driver. What I didn't expect though was what happened when I tried out my Freeloader port on real hardware. The Apple TV failed to even get to the Freeloader menu, instead giving me an error about hardware detection. It didn't take long to figure out where the issue was though, because the only hardware that is truly detected by Freeloader is the hard drive. Normally, Freeloader either uses BIOS calls or EFI boot services to read files off the hard drive. However, neither of these options exist on the Apple TV, so the only way to read the hard drive is with an IDE disk driver that talks to the hardware directly. A driver like this already exists in Freeloader though. I'm using it in VirtualBox. It's used in the NEC PC98 and original Xbox versions, so why won't it work on the Apple TV? Well, PCI IDE controllers essentially have 2 modes of operation, native PCI mode and ISA compatibility mode. The only real difference between the 2 modes, at least as far as I can tell, is that ISA mode controllers are always accessed using the same I/O ports, and interrupts are always fired from the same IRQ on every computer. PCI mode controllers, on the other hand, do not have standard I/O ports or IRQs. On PCI mode controllers, the I/O ports are the first 4 base address registers, or bars, in the PCI configuration space, and the IRQ is acquired the same way it is on any PCI device. As far as I can tell, PCI mode is worse in every way. Performance is identical to ISA mode, and it's just marginally more difficult to code for, which is probably why almost every IDE controller ever sold runs in ISA mode. But because think different, I guess, the Apple TV uses a native PCI mode controller. Freeloader doesn't support native PCI mode controllers, and that is where we run into our problem. To solve this problem, we either have to modify the driver to support PCI mode controllers or switch the controller into ISA mode. I ended up going for the latter because I assumed it would be less complicated, but in reality what I did was actually more complicated. Whatever, it made it easier to debug at a certain point, so it wasn't a waste of time. There's little in terms of documentation on how to switch the mode of the controller, since PCI mode controllers are pretty uncommon. But when bytes 0 and 2 of the programming interface register in the PCI configuration space are set to 0, the IDE controller will switch into ISA mode. I set up Freeloader to do this on the Apple TV before attempting to initialize the disk, and... oh my god, it works! It freaking works! First try, first fucking try. It actually worked. The Freeloader menu screen appeared on the Apple TV and it began to boot into the ReactOS install I had on the hard drive. Of course, it still didn't boot to the desktop or anything, but the Apple TV was now on par with VirtualBox in terms of functionality. In order to get any further, we need a working video driver. When discussing differences between EFI and legacy BIOS, the way that the frame buffer works is perhaps the most important one of all. Legacy BIOS is old, and I'm talking IBM PC 5150 old. And because of that, it was designed in a time where things like 32-bit color depth and megabytes of video memory were decades from the mainstream. Honestly, I don't know that much about how legacy BIOS video works, but I do know that it's pretty different than the way that EFI works and much more complicated. What's important for us is that we need a new video driver, or video drivers. See, Windows has two completely independent video drivers. The first one, known as bootvid.dll, is only used for displaying the Windows boot screen and blue screens of death. The second one is what's actually used for displaying the desktop. The basic driver for this is called vga.sys, but when you install an accelerated graphics driver, Windows will load that instead. And because ReactOS is designed to be a clone of Windows, all of that applies there as well. Well, almost all of this applies. We'll get into what doesn't later. When I first finished the bootloader, there was no EFI capable graphics driver for ReactOS because it wasn't finished yet. I had to wait a few weeks for some ReactOS developers, namely Hermes Belusca Melito and Justin Miller, to get video working on EFI ReactOS, but once they did, I quickly tested it out in VirtualBox. And if I did everything right, should boot to the desktop right now. No way! No f***ing way! We're in the desktop. We're running! ReactOS had successfully booted through my loader. But then I tried it out on real hardware, and things... well, they didn't work quite as well. Yeah, ReactOS kinda blue screened as soon as the driver loaded. I spent hours trying to figure out why ReactOS wouldn't load the driver. I scanned what boot logs I could get from the Apple TV, but I could never quite figure out where the issue was. After days of failing repeatedly to get anywhere, I decided to try a different approach. Instead of imaging a full install of ReactOS from VirtualBox to the hard drive, I tried copying the contents of the live CD image to the hard drive instead. This time, I got a different blue screen, but this time, I knew how to solve it. By default, the live CD image will use the non-ACPI version of the hardware abstraction layer, also known as the HAL, while the Apple TV absolutely requires the ACPI HAL in order to work. After changing the Freeloader configuration to use the correct HAL, I turned on the Apple TV not expecting anything to be different from before. I was so convinced that it would still be broken that I left the room and didn't even have my camera on during the boot process. But despite my expectations... holy shit! Wait a f***ing minute. How did this work? How is this working? What did I do to make this work? It actually worked. But sadly, I immediately encountered a problem that made ReactOS completely unusable on the Apple TV. The keyboard didn't work. That's right, the keyboard and mouse did absolutely nothing. The sensor on the bottom of the mouse didn't even light up, which means that no driver even tries to initialize it. I tried various cursed hacks to fix this to absolutely no avail. And that's because, as it turns out, the ReactOS HAL was doing almost everything wrong? I'm not going to get into the specifics, but let's just say it was a miracle that ReactOS runs on as much hardware as it does with how completely just wrong the HAL was programmed. I mean, it works okay on some legacy BIOS-based systems, but anything with EFI and any legacy BIOS-based system made in the past 20 or so years has problems or doesn't work on ReactOS for this reason. Some ReactOS developers started working on a fix while I shifted my focus to getting Windows XP running. Getting Windows XP to start booting with Freeloader was pretty easy. All I had to do was write a configuration file that told Freeloader where C Windows was and image over an XP install to the TV's hard drive. And of course replace the video drivers with the ReactOS ones that are supposed to work on Windows. Emphasis on supposed to. We'll get back to that later. While Windows did start on the Apple TV and the boot screen started to appear, I immediately got a blue screen of death. I expected a BSOD of some sort when booting Windows, but the one I got was not the one I expected, and this was really frustrating. According to this blue screen, the Apple TV was not fully ACPI compliant, which made no sense because ACPI worked fine on Linux and, as far as I knew at the time, fine on ReactOS. What made even less sense is that when testing in a VM, I didn't get this error, but I still couldn't boot all the way up because the ReactOS graphics driver didn't work. These issues very easily could have caused the premature end of the Apple TV project. I didn't like it. I didn't agree with it, but I knew that the only way to move forward was to do what I did next. This is Ghidra, a decompiler written and released by the NSA for public use. It's a publicly released piece of software, and they really want you to know it's public. It's so public, in fact, that the download has public in big letters in the name of the file. Makes me wonder what extra features the private version has. Anyways, I can use Ghidra to decompile Windows system files to figure out what's causing my issues. Windows gets the ACPI information in a very simple way. When Freeloader hands off control of the system to Windows, it passes in various pieces of information, including a pointer to the ACPI root system description table. Now, let's go into Ghidra and figure out how Windows deals with that information. After receiving the RSDT pointer from the bootloader, the ACPI driver checks the signature to ensure that it's actually being passed an RSDT and not all zeros or bogus data passed in by the bootloader. And this is the check that's failing on the Apple TV. Somehow, something is overwriting the ACPI data in memory with gibberish, but only on the Apple TV and not in VirtualBox. I decided to take a look at my memory mapping code. I'd set this up over a year ago at this point and never really touched it because, hey, it works in VirtualBox. In my code, I had the memory ranges used by ACPI set to either temporary or permanent memory used by the firmware because that's how they're set on the EFI version of Freeloader. However, that is not how they're set on the legacy BIOS version of Freeloader. On that version, they're set up as special memory. I changed my function to do the same thing as what's done on legacy BIOS version, booted it up on the Apple TV, and this is what happened. Okay. That's progress. That is progress. We're not getting an ACPI error anymore. Let's go! The Apple TV no longer displayed that blue screen of death, instead displaying a different one. Great. This issue was easy to solve though. All I had to do was manually force the hard disk drivers to load using a program called FixIDE, and the TV began to boot into Windows. Obviously though, since the desktop video driver is still broken, I couldn't actually get to the desktop. USB is at least partially working though, since when I plugged in a mouse and keyboard into the system, the sensor on the bottom of the mouse lit up. However, the caps lock key on the keyboard is still not lighting up, so the USB drivers aren't loading correctly. The only mystery left to solve about the ACPI issue is why it didn't happen in VirtualBox. And here's the answer. I don't know. I mean, genuinely, I don't know why it works in VirtualBox because the memory should be overwritten by Windows. But it isn't. I don't understand. But since the Apple TV is now booting to the point VirtualBox is, we have to move forward, and we have to get to the part of the project that I am absolutely dreading. The video driver. Again. Yeah, so the video driver. I'm not going to go through the entire process of how I got the driver to work because that's even more boring than the rest of this video, but I am going to talk about why the ReactOS driver didn't work on Windows and how I fixed it. My understanding is that Windows has support for two different types of desktop video drivers, plug and play and legacy. The only thing that you need to know about legacy video drivers is that, to my knowledge, they are completely undocumented. The only one that exists is Windows' default VGA driver, and there's no source code for anyone to base a driver off of because Microsoft never released it. All other drivers, including NVIDIA and ATI drivers, VirtualBox guest editions, and yes, the ReactOS EFI video driver, are plug-and-play drivers. When I replaced VGA.sys with the ReactOS driver, Windows XP thought it was a legacy driver, which of course led to... But by installing the driver in plug-and-play mode, it did load correctly. Installing the driver in plug-and-play mode can be done by using Device Manager and an INF file, or in Windows 2003, it can be done by replacing VGA PNP.sys with our driver. Windows XP doesn't have a VGA PNP.sys to replace, so we have to use an INF file for that one. Me loading the driver wrong was not the only issue with it though. The other issue had to do with the way the driver got the display information. On EFI-based computers, the memory address and geometry of the display have to be passed through from the firmware to the operating system. In this case, the data is passed through in a pretty similar way to how the ACPI data is passed through. There are two different ways in which a driver on ReactOS can acquire this data. The driver for the boot screen, which works perfectly on both Windows and ReactOS, uses a method that works on both of those operating systems. The desktop driver, on the other hand, uses both of the methods that ReactOS supports. But for one of those methods, it just stores the data in a place where it doesn't use it because alpha software, and it only actually uses the data from one of them. I'll give you 3 guesses as to which one it doesn't get the data from. It's the one that works on Windows. Yeah, I think we found the problem here. After modifying the driver to get the information from the other source, I copied the driver over to my virtual machine, and this is what happened. Is it frozen? Oh. Oh my god! Oh! Oh my god! Holy shit. I think I got a video driver that works! Oh my god! Oh my god! But of course, everything is too good to be true. When I tried it on real hardware, I still could not get any further than the black screen. The driver might as well have not been installed. It didn't matter whether I used Windows XP or Windows 2003. The boot screen would appear, the mouse would light up, but the screen would remain black. This was a pretty annoying problem to solve. This whole time, I've been installing Windows XP in VirtualBox and then imaging it over to the TV's hard drive. I can't run the installer directly on the Apple TV for various reasons, so I'm stuck doing it this way. In an attempt to figure out how the Windows installer works, I decided to install XP twice, once in QEMU and once in VirtualBox, and check what files are different between the two installs. And when I looked at what was different, I realized how lucky I was to have done this. When I installed Windows XP in VirtualBox, it automatically installed the hardware abstraction layer for ACPI-compatible computers using the PIC or Programmable Interrupt Controller. On the other hand, when I installed Windows XP in QEMU, it installed the one for the APIC, or Advanced Programmable Interrupt Controller. Now, this video isn't about interrupt controllers, but essentially all you need to know is PIC old and bad, APIC newer and gooder. On the Apple TV, setting Linux to use the PIC results in, that's it, the exact USB issues that I'm experiencing on Windows. The mouse lights up, but the caps lock key doesn't, and the keyboard doesn't work. I replaced the HAL with the one for the APIC, and the caps lock key started actually responding, but video was still not working. I decided to test this out on Windows 2003 because on that operating system I can literally just drag and drop a video driver and boot the system. But even when I did that, it still didn't work. That issue was literally just me being an absolute bonehead and replacing VGA-PNP.sys with itself instead of the EFI compatible driver. It took an embarrassingly long time for me to realize this, but once I did, I replaced the file and turned on the TV. As the Apple TV booted into Windows, my mind was racing. Not just with the thought that I might have finally gotten Windows running on the Apple TV, but also the thought that it was over. My magnum opus, the project that I had thus far spent 777 days working on, might finally be coming to a close. By this point though, I was no stranger to thinking I had gotten this close. When I made the desktop video driver work and when I had fixed the HAL issue, I felt the same way. But both of those times, thinking this only served to increase my disappointment when it inevitably didn't work. But this time, things were different.
My mouse came on.
Yes! 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 It's working! Oh my god! Oh my god!
Yes! Oh my god! Oh! No way. Holy f***.
We're not getting an ACBI error anymore! Let's go! How did this work? How is this working?
We're in the desktop. We're running.
"777 days after starting this project, Windows 2003 finally reached the desktop on the Apple TV. But what about Windows XP, I hear you asking. Yes, dear viewer, we're getting to that. Windows XP took another day to get working, and I'll tell you why. Unlike Windows 2003, XP has no VGA-PNP.sys that I can just swap out. That means that the only way to get the graphics driver to load is by using Device Manager on a running system to install an INF file. This works great when you have a working basic VGA driver, but since the whole point of this entire mess is that we don't, things get a bit more complicated. And it's all because of Windows trying to be helpful. If you boot Windows on a different computer than the computer it was installed on, it will re-enumerate all the hardware and assign drivers to it. Importantly for us, it will always assign the basic VGA driver to every video card, even when a better driver, like the EFI driver, technically exists. That means that we have to force the EFI compatible driver to load. Using another Windows XP computer, I manually enumerated the video card in the registry, copying exactly what VirtualBox was able to do automatically. When I put the hard drive back in the Apple TV and turned the thing on, Windows XP actually booted without any issue. And you know what? It ran pretty well too. The Ethernet worked out of the box, which was awesome. Wi-Fi and sound didn't work out of the box, but they worked once I installed the standard drivers for the devices that you'd expect for any other PC. The latest NVIDIA drivers for this card refused to work for some reason, so I thought accelerated graphics was a no-go. That was until a Mastodon user by the name of Guido Lewalder, sorry if I butchered that, got version 86.38 from 2006 working perfectly. Navigating around the desktop and using basic applications was downright snappy on the Apple TV. Way better performance than any Linux distribution I've run on this thing. I decided to upload a copy of the Apple TV's hard drive to the Internet Archive so that someone I knew could test it out on their TV. But as most of you probably know, they were not the only ones to see that Internet Archive page. Just a few hours after I uploaded my install to the Internet Archive, an unknown person found it. And that person sent it to DOSDude1. In case you don't know who DOSDude1 is, he's most known for the macOS patcher utilities, but he's also an absolute hardware genius and has upgraded soldered-in components on various devices. I'm not going to tell you everything that he's done because that would take like a month, but if you haven't already, you should totally check him out. He's awesome. DOSDude1 posted about my project to his 16,000 Twitter followers, and to my standards, it absolutely blew up. It's gotten over 2,000 likes and 200 retweets, and people started trying it out, including prominent tech YouTuber Michael MJD. Michael MJD tried and failed to do this over 2 years ago in a video. His failure to install XP was the spark that inspired me to start this entire project. When he made the video on my project, things really came full circle for me. The person who made a video that inspired me to start a project 2 years ago was himself inspired by the end result of that project and made his own video on it. And that is one of the most incredible feelings ever. So thank you, DOS Dude, and thank you, Michael MJD, for just being cool and liking my project. So, this was a bit of a long one, wasn't it? I'll have up-to-date information on how to install Windows XP on your Apple TV linked in the description. So if you want to try this out yourself, then check down there. Oh, and while you're down there, be sure to like and subscribe if you haven't already. This is the conclusion of 2 years of my life's work, so I really hope that you enjoyed it. The Apple TV is, to me, what the Commodore 64 was to Generation X. Like the C64, the TV is easy enough to program that a beginner, like me, could pick it up quickly, yet difficult and unique enough to be extremely fun. And yeah, despite all the ups and downs, despite the many times that I almost quit this project, despite all the frustration with how damn annoying the Apple TV is sometimes, this project was one of the most fun things I have ever done. When I was depressed and bored, going back to the Apple TV project and solving a few things here and there really helped me feel better every time. And this sort of thing might help you too. If there's anything in the world that you want to make, just make it. Whether it's something programming related, like a game mod or a piece of software, a 3D model, or really anything else, even like a song or something. Don't wait for someone else to make your dream into a reality. Go out and make it yourself. I promise you won't regret it. That being said, I'm never putting this much effort into anything ever again.